The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to Microtrac's free webinar about the Microtrac Sync, a hybrid laser diffraction and dynamic image particle analyzer. If you have any questions during the presentation, please type them into the question box in the control panel, and we'll be happy to answer your questions at the end of the presentation. A recorded version of this webinar will be available on our website, microtrac.com. Your speaker today is Terry Stauffer. Terry works closely with Microtrac as a particle characterization specialist, and he has over 50 years of experience in the industry. In today's presentation, we'll go over the concept of the sync and the modules and hardware integration. We'll also review the data for laser diffraction as well as image analysis. At the end of the presentation, we'll be happy to go over all your questions. And now, without further ado, I'll turn it over to Terry.
Thanks, Claudia. And welcome everyone to the Microtrac Sync Hybrid Analyzer. The Sync line is a combination of the two most important general-purpose particle characterization technologies, laser diffraction and dynamic image analysis. But why combine them? Well, for one, laser diffraction has been the most dominant particle characterization technology for decades now across all particulate processing industries and applications. It's the de facto standard for most. So both suppliers and users of particle-based systems use this same technology to verify the size specifications of the materials they sell and use. One perfect example is the atomized metal powder suppliers and the manufacturers of powdered metallurgy parts from those powders. Laser diffraction for outgoing QC by the supplier and for incoming QC by the user. Secondly, dynamic image analysis has rapidly become a much needed technology for quantifying multiple particle shapes as well as many more size dimensions. With the Sync, users can have the best of both worlds, the tried and true for continuity and the visionary, so to speak, to find new ways to improve product quality. So let's take a look at the major benefits of the Sync and Microtrac's approach in this new product. Sync features and benefits. For the Sync simultaneous measurement, the very same sample and user interface as opposed to two different analyzers and measurements on two different samples. An extended blended range, 0 to 0.01 to 4,000 microns in one sample. And self-connecting sample dispersion modules for the fastest, easiest changeover from wet to dry sample delivery in the industry. For the laser diffraction analysis, a unique non-spherical refractive index compensation which eliminates reporting false finds modes. Modified Me theory for correct reporting for translucent particles, and 3 diode lasers, optional red or blue wavelengths to optimize on different size ranges. For dynamic image analysis, 30 different size and shape parameters for detailed morphology on each individual particle. A view of every particle in the image file for fast qualitative analysis of the sample's overall morphology. A search feature which can be used to isolate different components or subpopulations in the sample. A filter function for automatically reporting or filtering out different subpopulations after analysis. And the ability to remeasure image video files to compare the effects of different SOPs without running a new sample. Here are photos of the Sync liquid dispersion module on the left, the optical bench and electronics, and the dry powder dispersion module on the right. The dispersion modules, each with its own sample cell and mounted on 4-ball bearings, can be interchanged within 10 seconds, with all tubing and electrical connections mating automatically. Some features and benefits of the FlowSync module for liquid sample dispersion: autofilling, deaerating, precirculation, and circulation for consistent repeatability, an inline ultrasonic probe with variable power for optimum sample dispersion, selectable SOPs, just add sample, click and run for ease of use and repeatability, a separate fill pump for water or solvent source for versatility, an auto drain, rinse, and wash feature to eliminate sample carryover. Here's the TurboSync dry module. It features a turbulent flow system for full sample dispersion. Adjustable airflow provides flexibility for free-flowing to tightly agglomerated samples. It handles samples as small as 0.1 cc for expensive materials for cost effectiveness. Measurement time is typically 10 seconds for high productivity. Selectable SOPs for ease of use and repeatability, and the quick one-step connect-disconnect feature for ease of use. Here's a top-down view of the Sync's hardware integration. One bench, one sample, one flow path, one sample cell, one measurement, one user interface, but 2 analyses and 2 complete data sets. Clockwise from the top, the laser diffraction hardware includes the 3 lasers with an option of red at a longer wavelength or blue, a shorter wavelength, for highest accuracies at different ranges, and 2 diode detector arrays on the right, measuring scattered light from 0 to 165 degrees. The sample cell, one mounted in each dispersion module, is located where the white arrow points. And the dynamic image analysis hardware includes the high-speed LED strobe at top and the optics and digital camera assembly in the lower left. The Sync uses a unique blend algorithm to calculate a size distribution which seamlessly combines the results of both the laser diffraction and image analysis technologies in the size range where they overlap. A few slides here on the laser diffraction data from the Sync. Callout 1 here shows the various tabs for the overall Sync software data: summary data, tabular data, raw data, Setzero calibration data, and the tab for size and shape for access to the image analysis post-measurement software. Below that row, callout 2, is the laser diffraction data in this display view. The list of summary data, percentiles, size percent, and peak summary, and below that, the distribution graph. To the right is a list of more features accessible: recall samples, validate, export and print data, set up pass-fail tolerances, create trend charts and custom reports, and compliance with 21 CFR 11. These are views of the laser diffraction tabular distribution data, the raw data showing light intensity on each channel, and the Setzero display removing background intensity. Tabs in the upper right of the summary data display pull up supplemental measurement information, all the settings for the SOP used, and security information. This is the set of parameters Microtrac reports for the sync image analysis data. Rather than go into each in any detail here, I'll describe in 4 general terms what they mean. First, of course, is size. We give you 12 different size measurements of each particle in various diameters, lengths, and more. The last 3 columns are shapes of different natures and are generally expressed as ratios of size parameters. Form factors include 10 different parameters that indicate how closely the particle is to being a perfect sphere, or various aspect ratios or elongations of the particle. Surface smoothness parameters are just that. 3 different parameters can indicate the texture of the particle surface. On a scale of 0 to 1, convexity and solidity values of 1 would be a very smooth convex surface. Concavity would report the reverse. 2 other parameters report the overall light intensity coming through the particle, transparency, and the curvature of the particle as a gradient of light intensity. Interim size parameters are used to calculate a number of shapes. But don't be overwhelmed. Only a few parameters are used for any one application. This slide shows the size shape data tab opened, call out 1, which displays some image analysis data as well as some selections for accessing more screens of image analysis data. The size distribution graph and tabular data are shown to the right. Callout 2 points to the summary data reported in this measurement SOP. Up to 60 different summary data choices can be selected to be reported for any SOP. Here we see some percentiles and additional application-specific data, and at bottom, the mean values of 10 of the 30 different size and shape parameters. A selection box where further image analysis information can be chosen is shown in callout 3, View Particles. Those screens will be covered in the next 2 slides. This is the particle viewer display in the Sync software. At top left is 1 camera frame from the saved video file. The lower left window is the complete scrollable image file. The text list in the upper right is a list of all parameter values for the image selected in the blue box in the frame and in the image file. The red vertical arrows indicate scrollable windows and window size adjustment. Selection of the Search Particles box, callout 1, opens the particle query window shown overlaying the frame. A search for images less than 70 microns in area equivalent diameter, DA, and less than a sphericity of 0.96 has been created and is listed to the right of the Search Particles selection box, highlighted in blue. When this search is selected, the image file then contains images of only the particles which fit into that search region. Any number of parameters can be entered into one search, and any number of searches can be created for one sample analysis. Callout 2 shows an area of selectable choices specific to the displayed image file. At the left is where displayed parameter value is chosen, sphericity in this case. The next 2 boxes show ascending or descending order. The parameter value can be displayed, and the image size scaling can be changed. Callout 3 points to the scatter diagram selection box. The next slide shows and explains this feature. The scatter diagram is very useful in identifying and isolating different groups of particle types. The scatter diagram itself is the area in blue. Each blue square shows where every particle in the sample is located relative to the x-axis distribution in the top horizontal graph and the y-axis graph to the right. Here the dA size is shown in the top graph and sphericity shape parameter on the right. A sphericity of 1 would be a perfect circle. Darker blue areas are regions of highest concentration. Percentile sizes are listed to the right for both dA and sphericity, as well as other summary data. This sample is a glass bead size standard and shows its main mode centered around 70 microns. There's also a very small fines mode at 40 microns and a larger region above 80 microns, which is made up of fused glass beads. Examples of the images in each mode were copied from the image file and are displayed at each mode in the scatter diagram. The X and Y graphs are shown in volume % format. This infinite resolution is possible because every separate particle in a sample is measured individually by image analysis. Each particle has its own signature of all the parameters. This is the level of resolution needed to detect very small amounts of contaminants or out-of-spec material in a particulate sample. In this sample, the fused beads are out-of-spec material. Here's a list of the current largest specific applications known to require both laser diffraction and dynamic image analysis technologies to measure their quality. Metal powders, referred to earlier, require high flowability and packing density for even, fast loading and high strength in final parts. Key parameters to spec are sphericity, smoothness, and size. Next, propants, which are sand or ceramic particles which keep fissures in hydraulically fractured shale oil or gas deposits propped open. The fissures need to allow high conductivity or flow rate to the surface. Key parameters as specified in American Petroleum Institute and ISO standards include Crumbine slot sphericity and roundness, as well as size. Granular fertilizer needs to flow well for even spreading and then evenly release chemicals into the soil. Key quality parameters are sphericity, smoothness, and a very narrow size distribution. Reflective glass beads used in highway safety coatings have to be highly reflective, be skid-proof by containing a proportion of added sand, and have a narrow size range. Key quality parameters are sphericity, smoothness, transparency, and narrow size distribution. Drug time release capsules need to have controlled, even drug release properties. Key parameters: sphericity, smoothness, and size. Extrusions made by granulation need to be of consistent length, diameter, and perimeter. Key parameters are aspect ratio, smoothness, and size. Abrasives used to clean, polish, or abrade hard surfaces need a spiky, sharp-angled external surface and various size distributions for different tasks. Key parameters are the Crumbine roundness and size. The lower the Crumbine roundness, the more sharp-angled the surface is. The previous slide focused on specific applications known to require size and shape measurements, but generically, all applications of particulate systems share the same problems, which can be readily identified and quantified by a combination of size and shape properties. The most common one is agglomeration, and the presence, absence, or amount of agglomeration might be good or bad for different applications. In most processes, it's an undesired feature, and size alone can't detect the degree of these first three generic problems. But parameters like smoothness, aspect ratio, and transparency can. Contamination from the process, sample handling, and packaging can be a serious problem for product quality. It may be in the form of oil droplets, shards of metal, glass, or plastic, but it can be detected and quantified by shape parameters. Too much sample debris in the form of broken glass beads, metal powders, time capsules cause quality problems. The debris can be isolated and quantified with shape parameters. Oversized particles in very small numbers can cause problems in processes like compacting, sintering, pelletizing, and granulation. But because every individual particle is measured in image analysis, it can detect and report the presence of even a single particle in a chosen size range. Only this particle counting type of technology can do that. And total particle count is always reported in a sync analysis. In summary, Microtrac Sync, the next generation of particle characterization technologies, combining simultaneous laser diffraction with dynamic image analysis, gives you a continuous blended size range from 0.01 to 4,000 microns. Laser diffraction is the de facto standard in most industries, and dynamic image analysis is rapidly growing in use as applications learn to use shape information to better control quality. Two different sample dispersion modules with rapid automatic connections provide adjustable settings for any level of desired dispersion. 3 options for laser diffraction wavelength combinations to optimize user-specific ranges. And specific and generic applications all need size and shape measurement. And that wraps up my presentation, Claudia. I'll turn it back over to you for questions and answers and wrap up.
Thank you, Terry. We actually have received a couple of questions, and feel free to continue submitting them. So our first question is it possible to get size only data and image only data?
Yes, it is. There are choices for that.
And how well is the calculated surface area from size and image data? Or they might be asking if it matches. I know we don't do surface area, but I think they're asking if the size and image data matches.
The size and image data don't match per se exactly, but that's why we have the blend algorithm. You can use the blend algorithm, which gives a very accurate representation of the combined analyses of the two technologies.
Okay, great. So we have a concern from one of our customers. They want to know if they can expect the sync data to agree with their S3500 data.
Oh yes, absolutely. We've checked that out.
Great. And this person says, I know that dry powder measurements often use small amounts of material. How much material can I run?
We actually have a selectable feature where you can run continuous samples. You can load the sample tray and run that sample, and then it will ask you to load the next portion of that sample, and it'll measure that. And after as many runs as you want, it will average all that data.
Okay, and someone is asking, can the sync be used with ocean sediments for environmental studies of grain size?
It certainly can. It's just another example of a particulate system, as long as they're within the size range of the instrument, and the range in laser diffraction goes down to 0.02 microns, and at the top end, up to 4,000 microns in the image analysis technology.
Okay, and someone is asking, can I save the results on a server?
Absolutely. You can also save the results of the image analysis in a video file, which you can then rerun under a different SOP to see what the difference in the settings might do.
A follow-up question, do I need to purchase special software?
No, the software all comes with the instrument. And as software upgrades later on in the life of the product are always free.
Okay, and someone wants to know the general price range.
I would like to refer you to your area salesperson, because we have about 8 different model types of the sync, and we would really have to know what your application is.
Okay, and someone is asking, have you already used a sync system to follow a process in real time?
I'm not sure if that means online or laboratory, but to get that straightened out, we do not have an online version of this instrument. It's a laboratory product, but we have followed processes from one unit operation to the other. It's no different from using a laser diffraction analyzer or another image analysis analyzer.
And someone just wanted to clarify if the software updates are free in the future.
They are.
Yeah.
They're free.
And do you offer technical support throughout the life of the instrument?
Absolutely.
As always, the presentation will be available for download or to view directly on our website. We use YouTube to embed it. If you need a special file format, please feel free to reach out. You can simply reply to the webinar invitation, and I'll get back to you with that. And sounds like someone's going to be at PipCon next week, and they want to know if we'll be demoing the instrument. And actually, yes, we will be. We have a slot for the demo zone on Tuesday at 1 p.m., so you can come see it in action. And you can also visit our booth, which is booth number 3939. Okay, and Terry, someone is asking if the software has an audit trail.
Yes, it's 21 CFR 11 compliant.
Great. Can we get into the details of how to do the calibration for that?
The unit is factory calibrated.
Okay. Someone is asking about the shelf life of the laser source.
We're using LED lasers. They last for 10, 20 years. Rarely have to replace a laser.
So going back to a prior question, I believe, do you see any problem to use it at line?
I would have to say that there's a difference between at-line and online. Online is when you're taking a sample from the process stream on a regular basis, like at an interval of every 10 minutes and getting a new result, and it's all automatic. At-line is when you're sampling the stream and making a run right there on the process floor. So we only have the laboratory version. It would be an at-line version or running the sample in the laboratory.
Okay. What is the lower size limit for image analysis?
For image analysis, it's about 5.5 micron in area equivalent diameter. Below 5 microns, you rarely see much difference in shape of particles because they all tend to start looking very spherical or blocky looking. You don't find many rod-shaped particles below 5 microns.
Okay, and do we have a qualification document? I assume the certification.
Yeah, you'll have to. I'm sure we do, but I can't refer them to anything. You'll have to have that person, or you can contact somebody in the R&D or engineering group and let them know.
Yeah, absolutely, I can do that. So someone is asking if you need to have a kit for calibration.
No. You can of course verify the instrument by using any NIST traceable particle standards.
Okay, and do you need to send the instrument back to your company for factory calibration every year?
No.
Okay, and can this instrument, the sync, be used to measure fiber? Oh, sorry, a lot of questions just came in. Sorry, I just lost it.
Well, regarding fibers, in the image analysis software, we can calculate fiber length and fiber width.
Yeah, they're specifically asking for fiber diameter as required for air monitoring.
Well, yes, we do measure that. We measure diameter and length of the fibers, but the lower limit is 5.5 microns, and I don't know that the air monitoring doesn't go a lot lower than that for requirement.
All right, and is there a need for a vacuum?
Only if you're using the dry dispersion module, the TurboSync.
Okay, and this is specific, but we are dealing with metal powders. What kind of module should we buy?
You could buy wet or dry, and we would be very happy to do testing in our applications laboratory to send you the results on either dispersion module. But it would be pretty much up to you whether you prefer to measure wet or dry.
Okay, and there's a couple concerns about calibration. Someone wants to know if they can calibrate locally, and also, I do believe you said this, but to calibrate, you use standards, correct?
To calibrate, we use standards and scaling wires, but the calibration, if an instrument would need to be recalibrated, and we don't anticipate that it really ever would, unless it got falls on the floor or something, and a lot of the some of the optics or the array detector alignments got damaged somehow. But if somebody would ever want a recalibration, we can make a service call.
Okay, and as far as software, is it does a Flex software run on 64-bit, and is it capable of running on Windows 7?
Yes, to both.
Great. Is the sync compatible with LMSS systems?
I would have to refer that to somebody in R&D also. I don't know if they've got that worked out to the point where it is working yet or not. I know it's on the agenda.
Okay, I can always find out and follow up.
Right.
So, are there special tools needed for calibration, and does it come with the instrument?
There are no tools needed by the customer. Calibration is just something that would very rarely ever be needed.
And someone is asking if the sync can be used for liquid and powder, and that's part of the beauty of the instrument, but I'll let you elaborate.
Yeah, we have two distinctly different dispersion modules. One is for dry, one is for wet. And the wet system handles both aqueous suspensions and solvents. You don't have to buy two different wet modules.
All right, it looks like the questions are slowing down. I know we had a lot today, which is great. I'm glad to hear that people are interested in the sync and learning more about it. If you have any further questions, please feel free to email us. You could reply to one of the invitations from the webinar. And as a thank you for attending, we're offering a complimentary lab analysis of your sample, whether it's imaging, laser diffraction, both, or DLS. You can simply contact our laboratory manager directly, Tony Weigel. Her email's on the screen. And if you have any questions, again, please email us or fill out the form on our website, and we'll be happy to get back to you. So thank you for joining us today, and we'll see you next time.